Welcome everybody to our today Diginomics seminar. We are very happy that, and I'm sorry if I pronounce it incorrectly. So Jeremy has, I don't know. So okay, we're a very warm welcome from our side. We are happy to have you here. And you will be talking today about entry into open source evidence from web browsers. What your current position is basically being a PhD student in management at HEC Lausanne at the Faculty of Business and Economics, and you focus basically on economics and strategies of innovation, as what I read at least. And you graduated from Paris, University Paris Panthéon Sorbonne, and you also have a master's degree. And as far as I read, you have an extensive international experience. So having lived in countries like Colombia or Ireland, so that's pretty impressive. But you also have experience in business. So basically, you worked in finance. So that's a finance background, and and investment banking. So for all the finance people in our group, that is already pretty good. So at the moment you're a PhD student, so maybe you can have one or two words about how you progress, what you plan to do later on. And so from our side, a very warm welcome. So sorry not to welcome you in Bremen, but maybe we can have that at one point in time. So we are looking forward to your talk. And yes, if you like, you can just say 1, 2, 3, 4 words, because a lot of the audience are actually PhD students. So they always also learn from others how to or how not to, depending on whether you have success or failure stories to share. So thank you very much for coming, and the floor is yours.
Thanks a lot. Thanks for this kind of introduction. So first of all, I wanted to thank Professor Arnouf to give me the possibility to present here. It's a great pleasure for me to present this work. I only presented a couple of times until now, and it's still a really work in progress project. So we are really welcome to any suggestion, comments, critique. Because we are still in a preliminary stage where we really need to hear feedbacks on what we've done so far. Just to sum up my background before, so yes, I work in finance after studying, especially in corporate finance, so in a company and then in a bank. But I decided to go back to the academic because I thought I had too much question to ask to work in a company, and I wanted to be able to still learn a lot and be curious and question things and not just process stuff as we can do sometimes in a firm. So this is why I joined Christian Peukert at HEC Lausanne to start my PhD, and I'm almost at the end of my second year of my PhD, and looking forward to produce more papers and start to submit to journals and present at conferences and keep on the academic journey that is made of high and lows. I think you all know, and so yeah, that's why I'm doing this. So I wanted to start this presentation with some examples of firms. So I wanted to question you if you think you can know what they share in common. So these firms' products. So if you don't have a clue, so what they share in common is that they used an open source technology as the base layer of their product, or so in part or full, to develop their offering. And just one example, New Yorker, so they decided in 2014 to really redesign their websites, and they adopted WordPress open source technology to do this. And so what we are interested in this paper is to really understand what happens when a firm like the New Yorker, adopt an open source technology, how it benefits to them, and how is that it affects the whole open source ecosystem. So why do we are interested in this question is that at the beginning of the open source software movement, it used to be dominated mostly by crowdsourced projects such as Linux operating system and Apache servers. But in the last decade, private firms have increasingly entered into the open source space, which is reflected in some of the leading open source projects today, such as React, led by Meta, TensorFlow, led by Google in the AI business, or Microsoft Visual Studio, which is an interface to develop code. And it is also reflected in the number of employees that are involved in the last decade. So this plot shows the top 10 companies that are involved on GitHub to contribute. And we can see this increasing exponential trend in the number of employees that are contributing. And we can recognize most of the big firms and tech firms of the world. And for us, it's interesting and it's still a puzzle to really understand what companies are deriving as benefits from this involvement of their employees. So they dedicate part of their work time to contribute to open source projects. So what is the benefits for the company that does that? And the entry of a firm can occur in several forms. So they can launch a new project, they can open source an already existing software that they have, they can contribute to existing project, or they can fork, which is creating a copy that is separated from the initial project, and then start to modify this copy and to make it your own. As open source projects are public, firm can assess the potential benefits of entering an existing project, but still it can backfire if the entering firm is not trusted. So recently we had these software wars in the open source world. So Amazon decided to use many open source technology in their cloud offering. So Amazon Web Services, and some of the leaders that were developing this technology, this open source technology, started to change the license, to change the way it can be commercialized in bundle offers. And so we saw that it's kind of a threat on the whole open source ideology, which is the idea that everybody can then take a version and do their own work around it. So there is this tension today between using open source technology for commercial purpose, but at the same time remaining a community-based development framework where you need to also keep the motivation high to be able to sustain the model. So this led us to two wide research questions. So first is, how does adopting an open source technology affect firm performance and value proposition? And the second one is, how do participants and competitors react to the firm's entry into an open source project? So previous literature highlighted the expected benefits of adopting open source for the firm. So even if some prophesize that open source software will lead to improved software quality, in fact, empirical evidence, which are difficult to collect, found no significant difference in quality between similar proprietary and open source software. But still, open source adoption has been associated with positive productivity gains, especially for firms with high IT intensity or in IT producing firms. And this we can also relate it to the fact that participating and using open source software can help to develop an absorptive capacity. And so then to use it for further on innovation. And at the same time, firms can use open source to also reallocate their resource internally and benefits from external contribution from communities. And finally, open source participation can help firms to attract, to detect and recruit talents, because they can observe external individuals that are contributing to their projects, and then if they want to recruit them, it's really helpful for them to already assess their qualities. At the same time, previous literature highlighted the participant motivations and why do individuals from all over the world are participating to contributing to a public good. So they highlighted that there were first the intrinsic motivations. So individuals are led by ideology, purpose, and also just to have fun outside of their day-to-day job. They also have internalized extrinsic motivation. So the economic literature show that it could help them to signal their abilities to learn, and also for reciprocity. So the fact that I will contribute to one project because I expect then the people I help to help me in the future. And finally, there are still extrinsic motivations. So participating to open source project can help to advance your career or to get new job opportunities. So there is still a monetary motivation behind participating to open source. And we also saw that in some journal articles that firm attributes, the sponsor of an open source project can shape participant intrinsic motivation. So we think that when a firm enters, depending on their characteristic, it will affect participant motivation, and therefore maybe the volume and the size of their contributions. So this is something that we will try to measure. So how the entry of a firm will affect the development activity of the project. So to do that, as an empirical framework, we use the web browser market. So I guess everybody in this Zoom meeting has used this morning a web browser. So I think we can all say that it's arguably the software that is the most used worldwide every day. So we are using it all the time, and yet nobody knows really what's inside these web browsers. And what happened in December 2018 is that Microsoft had web browsers that were called Edge, that were using a proprietary technology developed internally in Microsoft. They decided to adopt Chromium, open source base layer, to redeploy their newly developed web browsers. And it was an unexpected event for the competitors, because we saw in their reaction, for example, Mozilla was really made a blog post directly after the announcement saying that it was a sad day for the internet because it will lead to more concentration around the Chromium technology, which is already used by the market leader Google Chrome and other competitors. So we use this setting to understand how a private firm entering into a project affect the project and also the competitors. So just to explain the technology behind web browsers today, so they used to have mostly 4 web browser technologies. So the one developed in-house in Microsoft, the Chromium project, which is led by Google, but also used by a variety of software, WebKit, which is led by Apple, and Firefox with the Gecko technology. And so what happened with Microsoft decision, they are just moving in this technology with Google Opera, Yandex browser, Brave, and so on. And we have a reduction in the number of web browser technology. And also what is important to notice here is that all the projects that are remaining, so Chromium, WebKit, and Firefox, are open source. But 2 of them are led mainly by private firms. And why it is important, the design of the web browser, is that the web browser is the gatekeeper to the internet. So this is the application that enables you to access the content developed by web developers. And so it's a gatekeeper also for network effects between users and web developers. So web developers really are interested in knowing which device and which browser you will use, because then it will affect the way it renders their web page. So it's really an important tool, even if it's for free, in the way the internet is displayed today and is used. So adopting Chromium is a major change in strategy for Microsoft. Why? Because first, when they decided to release Windows 10 in 2015, they decided to, at the same time, reboot their software strategy. So they started to implement automatic updates to do a reduction in development costs, because they used to have many versions of Windows and the software associated in circulation. And so developers at Microsoft had to always port old version toward the new one with backward compatibility developments, which is really costly for Microsoft. And they also wanted to pull the plug for their iconic web browsers with a very bad reputation, Internet Explorer, but that was still used at that time by many users, especially in corporate environments. So part of this strategy was to also launch a brand new web browser that was developed internally, but it failed. Why? Because first, initial bugs and some incompatibility issues did not create the expected adoption momentum, which led to a small install base that reduced the incentives for developers to adapt their websites to run their own age. So it really reinforce these issues of incompatibility. And also, since Microsoft was developing in-house this technology, they struggled to follow the new specification, the new standards, especially because Google with Chrome have really influenced web standards. So they put many engineers in the committees that were deciding for new specification. So without external help, they really struggle to follow. And this is also one of the reasons why they adopt Chromium and not another competing technologies, because they would benefit then from this externality, the fact that Google is influencing web standards, to already have this positive externality on their side. And so they adopt Chromium, but it's still a U-turn, because back in the days, in the 2000s, Microsoft used to be a strong opponent to open source. So there is even the former CEO, Steve Ballmer, that called Linus communism a cancer to the society, even said at some point that it was anti-American to program in the open source way, because Microsoft thrives out of the protection of their intellectual property. So really, they were strong opponent to open source. But in the 2000s, at the end of the 2000s, they start to make some effort and to acknowledge that they made a mistake around open source. And in the 2010s, they increased their investment around open source. So they started with efforts to improve compatibility between the range of products Microsoft were offering and open source technologies. And this U-turn really peaked with the acquisition of GitHub in 2018. For those who don't know, GitHub is the biggest platform today to share code and to develop in communities. And so it was acquired by Microsoft in 2018. And at the same time, so the same year, there is this adoption of Chromium that also signaled this U-turn in terms of open source strategy at Microsoft. So putting our research questions in our empirical context, we are interested to measure what is the impact of Microsoft's decision to adopt Chromium on product quality. We also want to know how does it affect Microsoft web browser market performance. We want to know if there were spillovers to other Chromium participants. And finally, if Microsoft did crowd out contributors to Chromium. So to estimate this effect, we use several indicators of product quality, firm performance, and development activity. And our baseline model is the following. So we use some dummy variables to measure the period of announcement, the period after the release of the first Chromium Edge version. And we also use dummy for identifying Microsoft and also Chromium participant, but we are excluding Microsoft from the Chromium participants. So it's a kind of difference in difference empirical strategy, but with some some differences. So we are actually measuring averages by groups and by periods. So we are comparing before and after, but with a specific framework. And we are clustering the standard errors all the time at the right level to avoid potential serial correlation of errors because we are using panel data. So regarding data, so first we are interested in product quality. We have one first dimension is the functionalities. So we have collected historical data of all supported web technologies for all web browsers. We cover more than 500 functionalities, and it's a database that is used by more than 1.7 million users on GitHub. So web developers that are interested to understand what can and cannot do web browsers to develop their own websites. And so an example of functionality is what I represent on the right-hand side of this slide. So it's supporting, for example, the MPEG-4 format. So if a web browser is able to support this format, then we will have a yes, and if not, it will be a no. And that way we can look at what functionalities a web browser supports and the number and how it evolves around time. The second product quality dimension that we measured, so we didn't find a database regarding loading time because we have some measurements, but mostly from the vendors. So we decided to develop our own measure of loading time. And so we managed to collect data on web browser loading time for historical version of Google Chrome, Firefox, Microsoft Edge using a tool called BrowserStack, which is a cloud testing suite. So it enables us to develop a program. So we used a Python script to simulate a web browsing session, which shows two web pages, one from Wikipedia and one from Craigslist. Why? Because we wanted to have websites that were not evolving significantly during the past decade, to be able to really measure the loading speed and not a difference in technology, let's say, that makes that today it's compatible because there is more animated images, and so the old version cannot read it. And so we wanted to really take a simple text and image web page to make it like a baseline that after we can compare over time without having some incompatibility issues. And so for each web page, we measure the loading time using the web standards that are developed. And we iterated 30 times for each web page to really have a measure of dispersion around the average and to be able to measure a bit more the potential variability that you have after each session. So we have 30 times 2 web page times the number of versions for each browser. Finally, another dimension of product quality that interests us is the security of the web browser, because if you heard that there is a security issue with your web browser, you will maybe switch to another one. So it's still an important attribute for users to determine if they like or not, or if they will use or not a web browser. So we are looking at the patching activity of firms. So first, what you need to know if you're not familiar to software development, every software exhibits what we call vulnerabilities. So this is a bug or failure in the code that can be exploited by hackers. And so what do software vendors do? So someone in the crowd will discover the vulnerability. He will get in touch with the software vendor that will then know that there is this vulnerability. And so they will have some time to create a code, so a patch, that will be then released to solve this vulnerability. And then there is a delay between the time where the patch is released and the patch is installed by the users, because all users are not always using automatic update. So there is this small period which can be used by hackers also to exploit the vulnerabilities. And to attract reporters, what do software hunters do? So they implemented monetary incentives to report vulnerabilities. So depending on the severity of the vulnerabilities, reporters can get up to really large amounts of money, especially if it concerns a software that is really mainstream and used by many users, and that the vulnerability is really important. So we collected details on vulnerabilities because the vendors are publishing security updates release notes. And so it enables us to identify for each vulnerability the release dates of the patch, the severity, the description of the vulnerability, and reporter's name. So then we'll be able to quantify the number of reporters over time for each software. And usually vulnerabilities are identified with a unique identifier. So it enables us to really count and control that we are not counting several vulnerabilities several times. So just an example of a security update release note. This is the last release notes for Safari, which is made by Apple. And so we have the version of the software, the release date. We can find the identifier that I mentioned, and also the reporter name. So we can see on this one that there are two vulnerabilities because we have two unique identifiers, but we have one reporter that worked on both. So we are controlling for that, and we are counting the number of active reporters over time. Then we are also interested on firm performance and market performance. So we collected data on market shares and on absolute traffic. So market shares to really have a view by countries and versions and device. So we have data from 2009 onwards. So we can really look at how market shares for web browsers evolved across time. And we also have absolute traffic data thanks to Wikipedia that publish the traffic that they receive. And you know that Wikipedia is one of the top 10 most visited websites across the world. So it's really a good indicator of worldwide market share and worldwide usage of web browsers. So we can look at the versions that are used, devices and operating systems also with the web browsers from 2015 onwards. And finally, because of the public nature of open source development, we can observe development activity thanks to GitHub, the development platforms that I mentioned before. And so we managed to collect all the commits data for the three repositories that are the base layer of most of the web browsers today since their inception. And just to explain, a commit is a contribution that was accepted and implemented. It's a kind of peer review process, so a bit like journal articles. So you will suggest a change to the code, and there will be reviewers that will accept or not the change to be made, and then it is implemented if it was accepted. And so we can track the name of the person that make a contribution, his organization, the date of the contribution, a small description of what they changed, and we have also the size. So we have really a big database of development activity, which enables us to really observe what happens before and after Microsoft join for all the repositories that host code for web browsers. So I will directly jump to the results. So regarding product quality, the first dimension that I mentioned was functionalities. So what we can see is that Microsoft directly jumped after releasing their Chromium-based web browsers to the technological frontier alongside of the Chromium-based browsers. And so we can see that it's a clear effect of adopting the technology, and so they were lagging behind the competition, and by using this open source technology, they were managing to really catch up with the competitors. And the second aspect is when we look at functionalities and so the release cycles, is that adopting Chromium for Microsoft push them to adopt fast release cycle, which is a really different way to develop their software compared to what they used to do. So they used to average around 200 days before adopting Chromium to develop and release a new software, because they used to use the Windows release to release also web browsers. So they used to make big updates, but not frequently. While the standard, especially in Chromium-based browsers, was to adopt this fast release cycle, which is more incremental changes that you push every 50, 60 days to your users. And so we see that after doing this switch to Chromium, Microsoft had to adopt also these fast release cycles, which can be a kind of big change internally for developers, because it's a really different way to work than before. And an interesting fact here is that we see, so non-Chromium based were a bit slower in terms of release cycles than Chromium based. It's because there is heterogeneity inside this group. So Firefox follows almost the same trend as all Chromium-based browsers, but Apple Safari was most close to what Microsoft was doing, and they abandoned it at the end of 2021. So it seems that it starts to be the norm now to use fast release cycles. And one of the explanations we hear in the software development community is that it helps to prevent security flaws by pushing more frequently updates to the users. So we decided just to quantify this observation that we can make on the plot. So what we can see is that the initial gap for Microsoft to the technological frontier was about 96 functionalities. And this is exactly what they get almost in the post-release period. So they really just closed the gap that they had before to the technological frontier. We can see that the non-Chromium browsers have increased the number of functionalities over time, and that Chromium did not increase the initial gap that they have over the competitors. So it shows that the benefits in terms of additional functionalities came to Microsoft, but not to the all Chromium participants. So it's mostly coming from Chromium to Microsoft than something like a synergy between Microsoft contribution and Chromium participants. Regarding release cycles, as I said, so before the adoption, they averaged more than 200 days between two releases. And after they average a standard 53 days for the release cycle. So a second aspect that we wanted to study was to understand also the spillovers. So who is getting spillovers? Is it Chromium from Microsoft or Microsoft from Chromium? And so we wanted to look at the overlap of features supported by Microsoft Edge and Google Chrome just before and after the adoption of Chromium to measure potential spillovers from Microsoft to Chromium participants. So what did we do? We took the last version of Edge before Chromium, which is Edge 18. Sorry for the complicated number. And we took then the first version of Microsoft Edge based on Chromium, which is Edge 79, and we compare it to the contemporary of Edge 18, but developed by Google, so Chrome 71, and the contemporary of Edge 79, which is Chrome 80. So just to sum up in a figure, but it's maybe not that clear. So we compare these four web browsers between each other, and we try to understand what do each of them share in common and what is the differences and who maybe get functionalities from the other side. So just to sum up what we found that Edge 79, so the newly developed Edge based on Chromium, adopted 125 features that were present in Chrome 71, so the last version of Chrome before the announcement. So it means that 125 features flowed from Chromium to Microsoft, but only one feature flowed from Microsoft to Chromium. So what we show here is that there is almost no spillovers from Microsoft to Chromium, and that all the gain in functionalities came from Chromium to Microsoft. So mostly Microsoft kind of free riding the public effort made by Chromium participants before adopting the technology. We also find that 5 features were jointly adopted by Chrome and Edge. And then there is some specificities for each web browser. So 3 functionalities were only implemented in Edge and 1 was only implemented in Chrome. So then regarding loading times, so the results of our experiment that I described before, surprisingly, we discovered that Microsoft Edge was actually faster than its competitor before adopting Chromium. So even if it had a bad reputation, it was not as bad as the public opinion was saying about them. So just to explain, on the y-axis, this is time, but in milliseconds. So it means that in average, Microsoft Edge before Chromium averaged around 3 seconds to load the 2 web page that we selected, while its competitor were around 4.5 seconds. And we see that, so after adoption, Microsoft was slower then, but closer to its competitor because they have a similar technology. And we can see that for the competitors, they managed to decrease the loading time. And what is interesting then when we quantify, so we find this effect. But if you look at the last column, we look at the time functionality ratio. So we look at, okay, so they are maybe slower, but it's maybe because they can do more. So this is why also there is a trade-off between what you can do and the speed that you, and then when we control for the number of functionalities with the time, we find that actually Chromium was faster than Firefox because they have more functionalities and they work almost as fast as Firefox. And we can see that this ratio really improved for both Firefox and Chromium. So meaning that they managed to implement more functionalities and to improve the speed at the same time. So to really innovate in this area. Finally, the last dimension of product quality that we measured, so the security, we found that there is a diverging trend after Microsoft joins. So at the same time, Chromium and Microsoft are fixing more vulnerabilities after Microsoft joined the project, and are also attracting more reporters. And one of the explanations that we have in mind behind that is the monetary incentive. So remember the extrinsic motivation for participants to contribute. Here, maybe the concentration with 2 big firms working on a product that has a big market share makes that there is more rewards for reporters to work to identify vulnerabilities for this technology, and so make it more valuable for them, more monetary rewards. And so this maybe explain this effect. And so then we quantify it and we find what we see in the plot, that initially there were more reporters and vulnerabilities fixed for Chromium, but this gap even increased after Microsoft joined. So this is also a concern for competitors because it may signal that the security of competitors' web browsers is in jeopardy at some point because they are attracting less reporters to find vulnerabilities, and so potentially for users this is also a concern because it means that maybe the concentration around Chromium makes it more secure while the others are crowding out because of this event. So next, as I mentioned before, we are interested in measuring the effect on market performance following adoption. So we are looking at the market share. First, we look at the difference between desktop and mobile. So on desktop, here you can see first that Internet Explorer was still I don't know if you can see my mouse. Can you? Or yes, cool. Okay, so Internet Explorer was still an important actor on desktop in 2016, with being like the second most used web browser with Firefox, and the leader is clearly Chrome. This is a log scale, so be careful, it's multiplied by 10 each time. And we can see that after, so they launched Edge. It has a kind of small adoption pace, but still not enough. And after adopting, so yes, I didn't mention that, but the first dotted lines is the announcement period, the announcement date by Microsoft that they will adopt Chromium. And the second dotted line is the release of the first version. Sorry, I should have mentioned that earlier. And so you can see that after the release of the new Chromium Edge, they managed to get back to the second position in competition with Firefox and Safari for desktop devices. But on mobile devices, they really didn't manage to break through. And this is maybe explained by the fact that on desktop devices, Microsoft can push and market their web browsers thanks to their strong position in Windows operating system. With Windows operating system was on mobile devices, they have no traction because they don't have an operating system that is dominant as Windows on mobile devices. So it worked to get more visibility on desktop, but not on mobile. Then if we look at two things, so we differentiate between the product level analysis for Microsoft, because as you can see on the plots before, they have two products still on the market during this period, Internet Explorer and Edge. So we can see that, so this is the number of Wikipedia visits. We can see that Internet Explorer was the second web browser used to visit Wikipedia worldwide before the announcement by Microsoft to join Chromium. And we can see that this really plummeted, and today they really pulled the plug, and it's almost not used if we add the data on the year 2022. So they had to compensate this fall by Internet Explorer, the use of Internet Explorer. And what we can see is that they managed to increase the use of Edge at the product level. And so this can be seen here if we then aggregate the two market shares together and make just a Microsoft market share, so the golden line, we can see that they are in a less good position than before in terms of firm level. So it was a positive move at the product level, but still it didn't manage for the firm to reach back to where they were before. And it's even easier to see here when we normalize at 100 at the beginning of the period. So we can really see that Internet Explorer is almost not used today, while Edge managed to get the biggest growth of web browsers during this period, but it was not sufficient at the company level to not have a decrease of usage. And finally, the last dimension that we wanted to analyze, the development activity, we distinguish contribution between the one made by platform owners and externals. So here on these plots, we compare the Chromium repository to the non-Chromium repositories, which is the one that is used to develop Firefox and the one developed for WebKit, which is the technology used by Apple Safari. So what we call platform owners are the firms that are leading this project. So in the case of Chromium, this is Google. And in the case of WebKit, this is Apple employees. While external users from firms, but also any individuals that are contributing to these projects. So here are representing the 30 days moving average of the daily number of commits. Because if we look at daily data, there is really too much noise. So this is why we are using the moving average. So the first thing that you can notice is that software developers like Christmas because they work less at the end of the year each time. So we can really observe that, which is just a fun fact. But more seriously, what we can see is that platform owners really increase their commitment to develop Chromium during the period that we observe, while there is a decrease of contribution for external users. And then when quantify it, I will not show the regression results because it's a bit complex to show it on a slide because there are too many groups and so it makes it a bit more difficult to digest. But just to explain, we see a decrease for both repositories of the number of external contribution, but the decrease in Chromium is slightly smaller because they were already at a high level. So in percentage, it's a smaller decrease. We also wanted to look at the size of code change made by external and platform owners, and we can see that it decreased over the period for both. So we have a decrease in volume and a decrease in size. And finally, what we wanted to look at is to zoom into the Chromium repository and try to understand better what did Microsoft do around the announcement period and around the release. And so we can really observe that they start to contribute just before the announcement they made. And there is a reason why. It's because they started to, they communicate before the announcement that they will adopt Chromium, that they will port and help to develop and adapt Chromium to some processors that were used for Windows 10. And so this is why they just started a bit before the announcement, but we really see that they start to involve themselves in the Chromium project as soon as they announce that they will use it for their own technology. So we can really see in this slide that they don't contribute for fun. And Microsoft employees are really contributing if they can extract value from it for their own product. And we can see that the size of the changes that they make are roughly similar to the competitors. So this is really interesting to see that they really first contribute to the project, but in a lesser extent than Google or external contributors, but with the same standard of the number of changes that they make. And to conclude, we quantified the effects of Microsoft entry to the open source project Chromium. So what we find is that they managed to reach the technological frontier, but at the cost of being really similar to their competitors. So the differentiation aspects that they have before is gone. So they have maybe a better technology today because they have reached this technological frontier, but at the cost of being really similar, so which reduce the incentives for users to switch, because if I'm using Google Chrome, why should I switch to something that is very similar to what I already have, while before the product was more different? So there is this paradox of being maybe a better product in absolute terms, but being less attractive because you are too similar to your competitors. We also found that Microsoft engineers gave up most of what they done before. So this is something really important. Like in terms of management, they gave up 3 years of work suddenly just to adopt the technology that was developed before by competitors. It's really something that can be difficult to manage internally. And I will go back to this a bit later. And we also saw that Chromium adoption disrupted the way software development was done at Microsoft. So this is also something to manage, because they changed the way they were releasing software and updates. So this is also something that that is a strong internal change. And finally, we found that there are more contributors to report security vulnerabilities, which can benefit to all Chromium participants, but at the same time, we saw no or a small negative effect on development activity. So what we show here highlights some challenges that managers have to handle when entering an existing open source project. So since they have to give up most of what they've done before, you have to be careful regarding the potential not invented here syndrome that it triggers in terms of internal teams motivation, because since they've renounced to what they've done before, we can maybe imagine that it can create tension internally and resistance to really embrace the new strategy. Also, firms that are entering open source project needs to learn how to engage and work with communities, and this is really a long process, and you have to really be trusted and respected to be able to really capture value from communities. And finally, it has some implication for policy. So what we see is that the firm entry into an existing project leads to more concentration, which could lead to more inertia in terms of market shares and less innovation in the future. And we know that in Europe, for example, the European Commission is already concerned about the market power of big platforms. And we can see that it could reinforce Google Chrome dominance, because then the competitors that entered in the project is now very similar. So it could really reinforce the dominance of existing dominant actor. And but at the same time, the reduction in the number of technology can help to get more standardization and compatibility between web browsers and websites. So it could also increase social welfare in that sense. So thanks a lot for inviting me to present this work. And as I said, this is still a work in progress. So if you have any feedback, any comments, any critiques, we are really happy to listen to it. So thank you.